Cantilever beam made of spring steel. Modulus of elasticity is given. 25 millimeter long, has a width of 2 millimeter and thickness of 0.8 millimeter. Determine the spring constant. We need to find spring constant for this material. If all the lengths are subjected to measurement uncertainties of 0.5 percentage, determine the percentage uncertainty in the estimated spring constant. Uncertainty means what? Error. So a cantilever beam, modulus of elasticity E is given, length is 25, has a width 2, thickness T 0.8. We need to find spring constant K. If this is the cantilever beam, a rectangular shape, width is 2, thickness is 0.8. When load is applied, it deflects. When load is removed, it comes back. If all the lengths are subjected to measurement uncertainties of 0.5 percentage, so error in each measurement, whether length, width or height, error is 0.5 percentage. What is the spring constant? What is the force if the deflection here, if it deflects 3 millimeter downwards, what is the force applied? And what is the error uncertainty in the force measurement? This is the question. The question is that clear to you? We have a cantilever beam. A force is applied. Cantilever beam has a rectangular cross section, width 2, length 25, thickness 0.8. When force is applied, it deflects by 3 millimeter. If each measurement has an error of 0.5 percentage, what will be error in the measurement of the force? Is that clear question? Question clear?
Yes, doctor.
Yes, doctor.
Yeah,
Yes.
okay. Now here,
Yes.
what are the values we have? We have modulus of elasticity 200 gigapascal. So I converted 200 gigapascal into, I converted 200 gigapascal is the modulus of elasticity. I converted it into Pascal by multiplying by 10 to the power 9. Now in the question, width is given as 2 millimeter. So width is 2 millimeter. I converted width into meters, which is 0.002 meter. Thickness is taken as 0.8 millimeter. The thickness can be converted into meter as 0.0008 meter. Length of the cantilever beam L is 25 millimeter. So I have converted millimeter into meter here. The moment of inertia is calculated using the well-known formula. What is moment of inertia? Bh cube over 12. B is the width, h is the height. So width is 2, h is 0.8. So B is the width, which is 2, height is 0.8. So Bh2 cube by 12. Now for cantilever beam, we studied the equation for K. So we calculated moment of area, inertia. For cantilever beam, we know the equation for K. The spring constant is 3 EI over L cube. So E we have here 200 times 10 raised to 9. I is BH cube over 12, which we calculated, just changed millimeter to meter. So BH 3 EI over L cube. L is the length. We know the length is 0.025 cube. So K 3277 Newton per meter. This is how we calculate it again. So one of the slide in the previous example, if you remember in the previous class, one of the slides what we have seen here in module 4 in week 12, one of the slides here, I just want to show you this. This is the equation, force equal to K times X. Here, if it is a cantilever like this, K, look at this. This is our condition. We have three cases given here: rectangular cantilever, circular, and ring shaped. If it is rectangular, K spring constant is 3 EI over L cube. I is BH cube over 12. If it is circular, K is AE over L. If it is ring, K is equal to this. So if you look at this carefully here, the same equation we apply in here. Just a minute, please. We apply the same equation here. I equal to BH cube over 12, K equal to 3EI over L cube. And then we get the spring constant. So we have I already, we have spring constant already. Then we can find delta I over I. What is delta I over I? See, we measure the width, length, height. Each one has 0.5 percentage error. When I measure width, I have 0.5. When I measure length, I have 0.5. When I measure height, I have 0. So each measurement I have 0.5 error. That means delta I will have like B, I have measure error, T, I have error. So delta B by B the whole square plus 3 times delta T over T the whole square. Look at that. So I told you before, if it is t cube, it will be 3 times delta t over t. If it is b raised to 1, it will be delta b by b. So here square root of root sum square method, square root of delta b over b, the whole square plus 3 times delta t over t the whole square. This equation, is that clear to you? Because we are calculating delta I, change in uncertainty in moment of area by I equal to b raised to 1. 1 is the index. So that's why delta b by b the whole square plus t cube, that is 3 delta t by t the whole square. So delta b by b is 0.5, which is already given percentage. 0.5 square plus 3 times 0.5 the whole square. So the total and delta I over I in percentage is 1.58 percentage. So now you got delta I over I. Now you can find K. E is a constant modulus of elasticity, but L is not constant. There is an uncertainty of 0.5. So I we calculated, L we have. So delta K over K equal to square root of delta I over I the whole square plus 3 delta L over L the whole square. Look at that. So delta K over K equal to square root of delta I. Using this equation, 3 and E are constants. So delta K over K is the uncertainty of K equal to delta I square root of delta I over I the whole square plus 3 times delta L over L the whole square. So delta I over I we calculated 1.58 and then square plus 3 times delta L over L is 0.5 square. So using this we calculated delta K over K. Any doubt in this percentage? This one we studied last time. Any doubt in this percentage calculation?
No, doctor.
This is simple. Using the equations we have to do that. So what we have is, I'll explain. What we have is like what we have is modulus of elasticity, width, thickness. We calculated I, BH cube over 12. Convert millimeter to meter. We calculated spring constant, 3I over L cube for rectangular section. Then the uncertainty, first we need to calculate delta K over K, but delta K over K is delta I over I the whole square plus 3 delta L over L the whole square under the square root. But delta I over I we don't have, we have to calculate from here. So delta I over, first we have to calculate delta I over I, which is equal to delta B over B the whole square plus 3 delta T or T the whole square under the square root of. So we get from here delta I over I and delta K over K. So if we know K value is 3277, how to find delta K? So if using this equation, you can see 2.1. So delta K will be K times 2.18 percentage. So that value is written over here. That will be delta K 71.4 Newton per meter. So from here itself directly delta K is what? K times 2.18. So K we calculated from here 3277. So K is from here 3277 times 2.18 divided by 100 will give you delta K. Will give you delta K, and that delta K need to be added here. So here we need to find the deflection Y equal to 3 millimeter, which is the last question. Last part of the question is what is the force if the deflection is 3? What is the force if the deflection is 3? We know that the force is calculated as Kx or Ky. K we calculated as 3277. So 3277 is K times Y deflection, sorry, the deflection y is already there in the question, which is 3 millimeter. So k times y, k times 3 millimeter, millimeter can be converted into meter. So 9.83 Newton. So this is the force. So we have the force ky, k already we know k calculated, and the question is deflection is given as 3 millimeter. Now, what is the uncertainty of the force? Can we calculate the uncertainty of the force? So that answer is not given here. Can we calculate? And now the question is uncertainty of force. How you will calculate uncertainty of force? Can you explain to me?
Yes, doctor.
Uncertainty of force we need to calculate. How to calculate?
Like delta F over F equal to
Very
square
good.
root
Delta F of yes, square root of.
delta K over K
Very
square
good. Plus
delta Y over Y
over
square.
the whole square. That's it. Delta y over y is 0.5. Delta k over k we calculated here 2.18. So here delta f over f, which is the uncertainty, relative uncertainty of force, equal to square root of delta k by k the whole square. We have delta k by k 2.18 square plus delta y by y. Delta y by y is 0.5 square. So using that we can calculate delta f. So this you can do it as a homework, delta f. Is that clear? Any doubt in this question? Any doubt in this question?
No,
Any questions you have? Yeah, any questions you have, or it is clear, or anything I have to explain, just tell me.
no, doctor, thank you. But you can
It's okay.
the rule for force again, doctor.
See, rule for the force is we studied spring Fkx, the same equation. Spring F force equal to spring constant K times delta x. Here F is equal to K times Y. Spring constant, do you remember this equation I taught you? Here I taught you this equation. See this same equation, F equal to Kx. The same equation could be applied for cantilever also. F equal to Ky instead of Kx. That is the only difference here. Because the cantilever will act like a spring. Cantilever will act like a spring. That's why. Okay.
Okay, doctor. Okay, thank you.
Any more doubts?
No, doctor, thank you.
Okay, we will meet tomorrow. Okay. Thank you. I have a
Doctor,
yes.
this model we have lab or not?
No lab. Finished.
Finished, huh?
Yeah.
Okay, doctor, thank you.
Thank you. Thank you.
Welcome.
So we will meet tomorrow.